Hi, so I'm doing a project for the NASA. It's called LunaRecycle Challenge. So our team name is the Supremos. The team lead is me, Serge Saati. The team organization is Electron Valley, which is my company. My relevant past work is I was building motorcycle with gasoline internal combustion engine. So it's a internal combustion engine that works with gasoline. My geographic localization is Miami, Florida, and also we have an office in Montreal, Quebec. So in one sentence description, so we will recycle the material with combustion to melt them using hydrogen and oxygen and convert the heat into electrical power and recycle the waste. What specifically is innovative about my approach? So I convert the waste into electrical and heat power, and I use the electricity to produce more hydrogen to heat and recycle the waste almost completely and use the electricity to run other devices. How is it different from or better than recycling approach currently used terrestrially? On Earth, they don't use the heat produced by the hydrogen burner that heat up the waste to convert it into electricity, now produce more hydrogen and oxygen. How is it different from or better than the recycling approach currently contemplated for space application? Is different and better than the approach currently used in the space application because in space application the waste go through a high temperature reactor and the waste are reduced in size but they are not reduced completely and the heat is not converted into electricity and not used to produce hydrogen and oxygen. How does my approach leverage advanced technology or advanced manufacturing methods? My approach is using a hydrogen burner, a steam engine, and electrolyzer to heat up the waste and convert heat into electricity and to produce hydrogen and oxygen. How does it address the condition and activity of the hypothetical lunar settlement described in the mission scenario? The combustion of the waste will occur inside a pressurized habitat to be recycled into a finished end product. A. The system will recycle and heat up the waste and the moon inside the pressurized habitat. B. My system will be designed for the lunar condition and the pressurized habitat cause hydrogen gases at 50 Kelvin, which is about minus 146, minus 146 degrees Celsius, and an atmospheric pressure of 1 bar, since it liquefies at 20 Kelvin. Team are not okay to design solution. How my solution might be adapted to operate in a lunar condition, dust condition in the future, and how it will be inherently dust resistant. My solution will be adapted to operate in lunar dust condition because when the waste will be heated up into the temperature reactor burner, and the burner will be isolated from the dust because of the metal shield protection, and the heat will touch the water tank for the steam engine. No need filter for the burner since we use oxygen and hydrogen tanks directly. This engine my solution may have application or be adapted to have application to recycle system on the Earth, even if it's focusing to work on the moon. So yes, my solution has application to recycle system on Earth because the hydrogen and oxygen and the high temperature reactor will be adapted to work on Earth. Same thing for the steam engine and electrolyzer. Actually, on Earth, the oxygen tank will not be needed since we can use oxygen of the Earth. What waste category my process address, which waste category, what waste system will be processed. My process will address many type of waste as EVA waste, fabric, structural elements. Structural elements, not food packaging, that's a mistake. Aluminium structure, I will recycle aluminium 81% by mass and 81% by volume. Fabrics, clothing, I will recycle cotton, cellulose, 43% by mass and 33% by volume. Nylon, 5% by mass and 4% by volume. Polyester, 29% by mass and 22% by volume. EVA waste, cargo transfer bag, I will recycle Nomex, 92% by mass and by volume. Nylon, 3% by mass and 3% by volume. Polyester, 2% by mass and 2% by volume. Description of the user output produced from the process, including the type of the amount of kilogram and fixed of any finished end product. With the aluminum structure, I will extract the aluminum from them, melt them, and produce robot and vessel structure. I will use 810 kilograms of aluminum to produce 450 kilograms of metal for the vessel structure. Also, heat and electricity. With the clothing, I will extract the cotton, the cellulose, the polyester, and nylon from them, and produce cotton yarn and toilet paper roll. And I will use 31 kilograms of cotton and cellulose, 46 kilograms of nylon, 293 kilograms of polyester to produce 231 kilograms of yarn and toilet paper, also heat and electricity. That's for 1,000 kilograms of material. With the cargo transfer bag, I will recycle the Nomex, the polyester, and nylon from them and produce with the aramid fiber textile garment and cotton yarn and toilet paper roll. I will use 92 kilograms of Nomex, 3 kilograms of nylon, and 2 kilograms of polyester to produce 29 kilograms textile garment and also heat and electricity. What are the system and component that make up my process? Provided the explanation, schematic, and other relevant data for the system and component. To make my process, I will use both hydrogen and oxygen tank and a high temperature reactor burner that use the hydrogen fuel to produce water and fire heat and melt the waste, and with this heat produced, it will heat up a big water tank that evaporate water to make steam to actuate a steam cylinder engine to convert heat energy into motion. We also actuate a big electrical generator that power up some device into the space vessel station, and also power up an hydrogen electrolyzer using the water from the hydrogen combustion and electricity to produce more hydrogen and oxygen to circulate the combustion of the waste. And I will use hydrogen and oxygen compressor to compress all the hydrogen and oxygen and tank, and for each waste item I will create the feedstock from the material and use material to build other finished product like metal for robots. I will also use flashback arrestor, it's a safety gas device to stop the flame to reverse flow for hydrogen to back up the supply line with the gas burner to protect the crew and equipment from damage and explosion. Yeah. With easy product, with water. Okay, that's the schematic. So we see the hydrogen generator using the hydrogen and oxygen tank, using electricity for electrolysis, and a burner to heat up the waste, recycle them, and after that the burner will heat up the steam engine to activate the steam engine mechanical system to activate the coil of the electrical generator to produce electricity, and then use it for electrolysis or to supply the electrolyzer on top here, and also for the compressor for hydrogen. Here you see the melting scrap of aluminum. You see the feedstock for the metal that then become a lingo of aluminum. Then you same thing for the feedstock for the dyed cotton fabric waste. It become recycled cotton fiber and cotton recycled yarn. And here you can see the on the bottom the space vessel station. What's my concept of operation? My recycling concept work with an hydrogen burner. It uses hydrogen and oxygen tank to ignite a high temperature reactor burner to heat up the waste in order to recycle and melt them, and the combustion of the waste to produce enough heat to heat up a water tank to make the water steam and to activate a steam engine to produce rotation movement to actuate an electrical generator to power the space vessel station and electricity, and to power the hydrogen electrolyzer and the compressor to separate the water molecule into hydrogen and oxygen. We go back into the tank to heat up more waste, and that's a full cycle that we heat. And for which each waste item, I will have to create the feedstock from the material and use the material to build other finished project, for example, metal and stuff like that. And for each cycle duration will be 1 hour for about 1,000 kilograms of waste. It will take about 4 full production cycles to recycle the aluminum structure into aluminum to produce vessel structure, 3 cycles, which 3 hours to recycle the clothing into cotton, cellulose, polyester, and nylon to produce cotton yarn and toilet paper roll, and 5 cycles, which 5 hours to recycle the cargo transfer bag and Nomex, polyester, and nylon to produce the aramid fiber textile garment and cotton yarn. Toilet paper roll. Now, operation we need many crew, one to control the high temperature at the burner, another one for the waste property and the good location, and a third one to to maintain steam engine with water tank, and they want to build freezer, and they want to build recycling material, so 5 square at least. What maintenance my system will need to my process complete one more cycle. My high temperature actor burner okay, maintenance to change the spark plug, the ignition system coil, the hydrogen injector, the regulator for the flame, and I need one crew for that. Also, my steam engine need maintenance to adjust the valve and replace piston and replace engine shaft, water steam exhaust valve and intake, and I need one screw for that. And so my electrical generator need crew for the cable, magnetic coil, and also my water electrolysis need maintenance to replace electrode to verify the acid is good and I crew for that. So 4 crew in total. Describe my resource, including electricity, cool time. So for the waste category, structural element, which is aluminum structure, aluminum, the electricity, peak demand over 4 hours, 280 kilowatt. Total electricity consumed, 1120 kilowatt hours. And because I recuperate 700 kilowatt hours, so my net electricity consumed will be 420 kilowatt hours because 1120 minus 700 will be 420. 980 grams for the water for the cruiser and for the steam engine because I'm using 20 kilogram of hydrogen, 160 kilogram of oxygen, so that is 180 kilogram of water. But I also use 300 kilogram of water for purification, for cooling, and another 500 kilogram for the steam engine. For 145 kilogram of sulfuric acid, 30%, 1,000 kilogram of aluminum structure. I need 5 screws to operate the system and 4 hours to the process, and 4 screws to the maintenance of the same. It take 2 hours every process. Peak demand over 3 hours, 375 kilowatt, something 1120 kilowatt hours, 420 kilowatt hours, 980 kilogram, 125, that's the same thing. That's for the fabric, clothing, cotton, polyester. That's for the EVA waste, the cargo transfer for electricity. Peak demand 5 hours, 225 kilowatt hours. Same energy, 1120 kilowatt hour, 420 kilowatt hour. 900 kilograms for the water for the electrolyzer and the steam engine. 20 kilogram of hydrogen, 160 kilogram of oxygen, 100 kilogram of cargo transfer bag, 145 sulfuric and electrolyzer, 5 crew to operate the system, and 5 hours for the whole process, and 4 crew to operate the system, and 2 hours for the process. Describe the type of amount of initial output will be received from a process. Initial output are defined the definition above. When I receive the aluminum structure, I will produce initial output such as reduced gas like nitrous oxygen, greenhouse like carbon dioxide. It produce 280 kilograms of carbon dioxide for 1,000 of aluminum structure and 15 kilograms of nitrous oxygen. When I recycle the clothing, I will produce initial outputs like a greenhouse gas like carbon dioxide. It produce 3,200 kilograms of carbon dioxide for 1,000 kilograms of clothing. When I recycle the cargo transfer bag, I will produce initial outputs like hazardous gas like nitrous oxygen, greenhouse gas like carbon dioxide. It will produce 210 kilograms of carbon dioxide for 100 kilogram cargo transfer bag. And for the following waste table to show the recycling phase one challenge. So for the structural element, for the aluminum, 90%, nothing for the ones 90% total. For the fabric, for the clothing, 77%. And for the AV waste, for the mask, the protective mask, that will be 100%. And this digital digital twin, what much digital design approach is called physics basic simulation. So I'm creating a PDF file with schematic to present my project, and I will make a video and clip animation with PowerPoint and Macromedia Flash to put a video and convert it to MP4 and upload to YouTube. The video will represent the simulation and visualization of the recycling project and the electricity generating from the electrolyzer and high temperature reactor burner with hydrogen and use simulation software to test the system. Level of the fidelity to the most closely. My digital representation has a high level of fidelity and resolution because they demonstrate the real world very accurately, showing the heat produced The electricity used to activate the electrolyzer and the compressor to produce the hydrogen. It showed the high temperature reaction burner with the hydrogen action and showed the steam engine and electrical generator and showed the metal is met and how the closing up and recycled. Describe the sensor inside the hydrogen high temperature afterburner. There is some sensor for the temperature and pressure to enter safe temperature and pressure to regulate and to avoid over temperature and pressure from the tank and burner. There is also a sensor in the steam engine water tank to monitor temperature and pressure to be sure that the pressure is high enough to actually create the cylinder but not too high to avoid explosion of the tank, and sensor to monitor the rotation speed of the steam engine, and there is voltage sensor for the electrical generator and sensor for the temperature of the electrolyzer to prepare more water if it's overheat. Pressure sensor for the hydrogen compressor and so temperature sensor for the recycling area close the burner to be sure the waste as aluminum is a proper temperature is 2000 Celsius to melt properly and one equal properly. So the system is continually monitor safe pressure, temperature of each system, such as temperature at the burner, electrolyzer, steam engine, and recycling area of the burner. And the observing system is counting and maintaining the electricity used for the electrolyzer and hydrogen compressor. Water used for cooling and doing the electrolysis and measuring the compression of the hydrogen and measuring the electricity produced by the electrical generator for the data acquisition and integration to check if everything is working properly and effectively. Describe any automated control and decision-making capability. There will be software into a microcontroller module that controls the operation of the hydrogen high temperature afterburner and electrolyzer. It receives the data from the temperature sensor from the burner and pressure sensor inside the hydrogen tank and automatically control the flux and regulate the pressure to optimize the performance and the security of the system as you make decisions to reduce the flux limit of hydrogen if the burner temperature becomes too high, and regulate the compression of the hydrogen compressor that fill the tanks and also control the water level of electrolyzer to increase the flow of water within the electrolyzer to cool it down during the electrolysis process and regulate the electrical current to supply the electrolyzer to maintain a safe temperature and a steady flow of hydrogen and purify the water that contains sulfuric acid and maintain a good acid concentration. The system also controls the burner to avoid too much steam inside the steam engine and regulate the valve and the cooler of the condenser line to convert the steam into water to restart the process of the steam and regulate the pressure of the steam to avoid too much rotation speed of the system engine to break down. Also to regulate the speed of electric generator to regulate the production of the electricity by the electrolyzer of the hydrogen compressor and the second process regulated with proper heating of the burner and for the cattle operational aluminum, the waste produced the feedstock and functional product. Artificial intelligence, the SEM will be able to make decisions on its own, think by itself, and predict what the best outcome to control the pressure. The microchip inside the circuit board will be able to monitor the electric demand and the quantity occurring for the recycling and be able to know at which time of the day the demand will be higher. So if afternoon people emit more waste, the SEM will produce more heat and there should more hydrogen to be burned to heat up the waste tank and release more steam to accelerate the steam engine to produce more electricity to supply the recycling system prepare more electrical power to supply the electrolyzer, to supply more hydrogen, and automatically release more cool water to cool down and to design compressor and burner will take more hydrogen to produce more heat to melt aluminum and recycle the waste. Describe my approach for virtual prototyping and testing my performance for functionality and simulated environment. My expected approach will be use a simulator and a video prototype to show the system work and perform its performance and functionality. The virtual prototype and simulator will show the high temperature, hydrogen, and oxygen, and the recycling device portion, the electrolyzer, the system engine, and the electrical generator and hydrogen compression working, and will show the heat production from the burner, will show the waste heat inventory, and to the recycling device, heating up, melting, and then transforming into a feedstock, and then and finishing end product, and also the animation will show the electricity flowing from the electrical generator into the electrolyzer and will show the water being separated into hydrogen and filling the high temperature afterburner. It will use software for digital animation and software for simulation as electricity, heat, and gravity to make a simulation for of all that. the simulator will take the heat and transition to the point if the waste is ready to be melted and transformed chemically into feedstock, and we calculate the electricity and the heat used and a way to make the system work. Describe my validation approach for computer model example how to do the model prediction or output in the real world Internet future system. By validation approach, we use the computer model for the simulation, and we use the simulation software to get data acquisition and data integration to monitor the temperature, pressure, electricity, and mass of waste and water for the model prediction to predict the output and input, and will align very accurately with the real world because my software is very well calibrated with temperature and pressure data. It uses accurate data and accurate calculation to calculate the right amount of electricity, mass of waste, temperature, pressure, and current, threshold, made aluminum, other waste recycle them. Describe or communicate with physical assets for the Internet physical system. My digital twin really represent the real physical asset of the Internet video physical system. All part and same of the digital twin as the such as the hydrogen, high temperature turboner, recycling unit, hydrogen compressor, hydrogen electrolyzer, steam engine, and electrical generator representing all physical assets exactly well of the physical project system that we intend to build in the future and for the space vessel station because they describe the same and operation very well and accurately. So the physical SEM that we intend to build will be exactly the same way as the model of digital twin will send data and number. Accuracy. So my digital twin prototype reflect very accurately the real-world physical asset because the simulation and visualization are using real data and accurate calculation that would be very identical to the real-world system. So data have a high degree of fidelity and the model also high level of fidelity and high level of predictive capability because it's very accurate because it demonstrates the real world very accurately, showing all the data and showing that was going to happen in the system. Cohesion, all the parts of my digital representation of my digital twin are very well coed between each other and they're closely coupled between each other. All the parts of my digital representations as the model and simulation which include the hydrogen, high temperature, thermal recycle units, steam engine, electric generator, the hydrogen and the hydrogen compressor are close connected between each other because the hydrogen burner is using the hydrogen tank to produce heat to supply the recycling unit and water bath tank and the steam engine to actuate the steam engine to the generator to the supply line, electrolyzer and the supply electricity and hydrogen and oxygen compressor to produce and compress the hydrogen and oxygen into the tank. The hydrogen and oxygen from the tank goes from the generator when the unit is using the heat produced by the burner. All the components of the model and simulation are playing compelling with the law of physics activity because use the temperature and pressure data from the environment burned at the actual real temperature of the real physical system to make the metal for the recycling unit and the water and the steam engine will evaporate at the real temperature getting its heat from the hydrogen burner and the steam engine will burn at the real speed causing the actual speed pressure when you spin electrical generator and produce the real amount of voltage and amperage to supply the electrolyzer and hydrogen compressor. The electrolyzer will use the real amount of current electricity to supply the water into the real amount of hydrogen and oxygen, and the compressor will compress the hydrogen and oxygen using the real amount of electricity and the same pressure. The real physics twin system and the burner will use the same amount of hydrogen and oxygen and produce an amount to it activate recycling units. Water tank and steam engine, and the simulation adapt very well to the law of physics at the same as the real physics and twin system do. Flexibility management is very flexible. The evolution of the change of technology of the asset because of the economic system can be compatible with the new technology system. For example, if the electrolyzer change type of technology using other type of electrode or acid and water will still produce the right amount of hydrogen and oxygen to enter in the compressor and supply the high temperature reactor burner even if we change type of compressor. It will still compress the hydrogen the same pressure and the hydrogen burner can change also and it will still heat up the recycle unit and steam engine at the same temperature and we will also can also change type of steam engine or type of electrical generator and they will perform at the very power the same where is the amount of electricity. So yes, the digital twin and the physical asset are very flexible, and the digital twin representation has a high level of ability to adapt and change the same way as the real world physical system will have to change in the handle increasing complexity of the physical asset technology and those assets involved technology. Predictive capability, my digital twin prototype and simulator have a high predictive capability to anticipate the future behavior of the real world physical asset because the way the simulator is programmed, knowing all the real data and calculation, it shows exactly the amount of hydrogen, oxygen, water, and electricity required to run the recycle system, and hydrogen burner will predict the lifespan of the spark plug, the ignition system, coil, and the hydrogen injector of the hydrogen at temperature burning determine whether the same will need maintenance, when it will be failed, and when perform will be reduced. Performance over time, the performance of the hydrogen burner will be reduced and it will produce less heat with the same amount of hydrogen and require more hydrogen to give the same performance. The regulator will reduce only the gas flow and if we will take that into consideration, we also take into consideration of the rear and the steam engine and the wire and the mechanical winding of the electrical generator that will reduce the efficiency of less electric power and also the rear of the hydrogen compressor and the loss of efficiency of electrolyzer because the electrodes are going to be out digital portable anticipate actually the future loss. Repeatability, my digital twin are very reliable and can be repeated and replicated and will always work and function as expected across many scenarios, such as different temperature, different pressure, different quantity of recycled waste, depending on the usage and need to the product and the space. This decision some items are going to be recycled more often, but the digital twin will always perform the same way and perform similar data and produce similar electrical energy and output and similar quantity of mass. The same way the digital world physical prototype will be available overall. Usability. My digital twin is very user-friendly and very easy to use. There is no need to be advanced scientific to use it. They have the basic of knowledge about the recycling, about the principle of the hydrogen, combustion system, gas compressor, electrolyzer, and steam engine, and see the creatively smart enough to be a scientific time, which means even at 15 years old, high school student and science option can easily use it and understand the legal science, physics, chemistry, that are all teach in school for students with program. User can interact with digital twin with ease, understand perfectly, integrate or to exploit it. They will be deliver and operate digital representation of digital asset very easily. They will- And digital tools in protect and confirm efficiency and decision making. The user will be able to make it and his decision using the control team control verification and validation of the twin of the various model. Magic Twin made the experiment very well. My, my model are made by video animation and digital representation, and they will connect together to present the different real world physical assets will be connected together. All the parts of the system will be connected together using the program and the simulator and the visualization using the proper sending the stream data. It will test thoroughly the digital twin editing simulator and the visualization of the analyze the data and functionality of the system is identical, so is the same, is good as a temperature, pressure, electrical power, and mass of the waste of the item. I will demonstrate that the electrical energy is recuperated, that the hydrogen is compressed and at the good pressure and temperature, that the electrolyzer is going the good amount of electricity, the good amount of hydrogen burner, and make good analysis data, confirm data. Process of the premise model is accurate and present the real world system, the simulator and visualization test and data check functionality and simultaneous time, see if actually time. My vision was created with PowerPoint, software display page. It incorporates video animation, pictures, schematic, slide. It showed animation of this simulation of digital twin as the represent the real world and affect the circumstances of the moon. Electricity used by the trigger and the compressor and the hand system, the generator. That's the basic challenge. Very condition. Easy approach, category, stability, array. that's the burner, everything like that.